here's another ice table that's a little bit trickier. So let's break it down. We're going to have to use the equilibrium law expression and substitute in x's to algebraically determine the unknowns. So here's my reaction. Nitrogen and oxygen react to produce nitrogen monoxide. I've got the Kc value, the equilibrium constant value at a temperature. And so here's the problem. In a 2-liter flask, 0.4 moles of nitrogen, 0.4 moles of oxygen react to equilibrium, establish the equilibrium concentrations of all of the gases. So the first thing I need to do is to figure out the equilibrium law expression, the Kc expression. So Kc will equal my products, so the concentration of nitrogen monoxide, but this has got a coefficient of 2, so it will be squared, divided by my reactants, which will be my nitrogen concentration, multiplied by my oxygen concentration. These guys are all gases, so they're all going to get included. So now that I know my Kc, and we know the value too, right? Kc is equal to 8 times 10 to the negative 2, so we're going to need that information a little bit later. Let's set up our ice table. So we have our nitrogen plus our oxygen reacting to give the nitrogen monoxide, my initial concentration, my change in concentration, and then the equilibrium. And these will all be in moles per liter. So let's put down the information that we know. I know I've got a 2-liter flask with 0.4 moles of nitrogen and 0.4 moles of oxygen in it. Now I have to be careful because this is another one where I'm being given the amount, but it's not a 1-liter flask. So to find the concentration, I need to take my 0.4 moles in my 2-liter flask. Well, that gives me 0.2 moles per liter. And that's going to be true for my nitrogen and for my oxygen here. So my initial concentration is 0.2 moles per liter. And I'm assuming I'm starting with no product because if we had some product to start, we would have told you about it. Then I don't know any of the equilibriums, so I'm going to have to use some algebra here. I know that my reactants will decrease by some value, we'll call it x, and they will both decrease by x. My product will increase, but it's produced at a 2-to-1 ratio, so it's going to increase at a rate of 2x. It's going to change by 2x. So then my equilibrium concentrations for my nitrogen and my oxygen will be 0.2 minus x and 0.2 minus x, and my NO will be 2x. So now we can substitute these values into the Kc equation and we can solve for x. So we can copy the Kc equation down here. It was my product, so my nitrogen monoxide squared divided by my nitrogen times my oxygen. So then I can sub in. Now I have to be careful here because my 2x is not 2x with just the x squared. It is 2x all squared. And on the bottom, these guys, 0.2 minus x times 0.2 minus x. And all of that is equal to my Kc, which was 8 times 10 to the negative 2. Now I notice here that I've got perfect squares because my Kc, 8 times 10 to the negative 2, is equal to 2x all squared divided by 0.2 minus x squared. So these are perfect squares. I can square root and square root, which will give me the square root of 8 times 10 to the negative 2, which is 0.28 equal to 2x divided by 0.2 minus x. My squares are gone. That's going to make my life a lot easier. So then let's get this term on the bottom up to the top by multiplying by 0.2 minus x on this side, multiplying by 0.2 minus x on this side. Those guys will cancel. And then we can multiply this in. So it gives me 0.056 ... minus 0.28 x, which is equal to 2x. Then let's add this to both sides to bring it over, plus 0.28 plus 0.28 ... x. These guys will cancel, and that's going to give me 0.56 is equal to 2.28 ... x. Finally, to get x by itself, we can divide by 2.28 with its change on this side, divide by it on this side too, and x will equal 0.0248, my 3 sig digs. Then I need to sub back in so that I can sign off on this bad boy. So here's my value of x. My product, its equilibrium concentration is 2x. So I need to double this, which will give me a nitrogen monoxide concentration of 0.0496 moles per liter. These guys are 0.2 minus x. So that gives each of them a value of 0.175. So for my oxygen, its equilibrium concentration will be 0.175. My nitrogen will be 0.175 moles per liter as well. So here's my equilibrium concentration number 1, number 2, and number 3.